Okay, so let's plug in these numbers. So we've got 4 to the x power, and we're plugging in 4 for x. So this is 4 to the 4th power, which I think is 256. Okay, over here, now this is the important part of all of this. That one was easy. Okay, I'm going to plug in -2 right here. So 2 times 3 to the -2 power. And I can put that in parentheses again. You have to remember the order of operations. Okay, that means that the parentheses go first. I've got my 3 in parentheses. There's really nothing I can do in there. Then the exponent. Then I do to the -2 power. So this is 2 times 1/3 squared. And then I multiply. So this is 2/9. We don't do 2 times 3 to the -2 power. That is you'll get the totally wrong answer. Okay, so just remember, you've got to do this one first. So let's look over here. We've got 1/2 times 4 to the -2 power. So I'm going to do this one first, order of operations. 1/2 times 1/4 squared is 16, so I have 1/32. And then over here, it looks tricky, but you got it. You can do it. Well, I mean, you don't have to do it now, but you could if I gave you the chance. So I just rewrite it like this. Remember, this goes first. 2 to the 3rd power is 8. So this is -8/3. All right, so when we are graphing exponential functions, there's basically 4 of them. And they're 2 on this graph, 2 on this graph. And I'm just going to show you examples of what these would look like. So for example, this one that goes up like this, that could be 2 to the x power. Now when it's flipped, it's the same thing, but it's flipped over the x-axis. This would be -2 to the x power. Over here, it's coming down. So an example here would be 1/2 to the x power. This would be a number between 0 and 1. Okay, and this would be flipping it over the x-axis, which would be -1/2 to the x power. We'll talk more, we'll see this in the next lesson too. Okay, so let's graph these. And first we're going to talk about, it says compare the graph to the graph of the parent function. Describe the domain and range of f. Okay, so my parent function for this one is going to be f of x equals 2 to the x power. Okay, probably should have made this a g of x because it's not the same as that one. Okay, but what's happening here, well, I'm comparing the graphs. So let's graph this. I'm going to make myself a table. I think I'll start with -1. If I go down too much, then I get into fractions and it's hard to graph those. So we're going to go with these. So -1, this is 1/2. 0 is 1. 1 is 2. 2 is 4. 3 is 8. Okay, so I'm going to graph this. -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. All right, so this graph shouldn't come as a shock at all because I just showed you one just like it. But once we throw that 4 in there, okay, 4 times 2 to the x. Let's make another table. -1, 0, 1, 2, 3. So this is 1/2 times 4 is 2. This is to the 0 power. This makes this 1, so this is 4. If I put a 1 in here, this is 4 times 2 is 8. I probably should have gone a little bit lower, but here is this one graphed next to its parent function. So I've got -1, 2, 0, 4, 1, 8. Okay, so this is going to come down like this. Okay, so let's talk about, well, first of all, let me finish my thought. I'm getting ahead of myself. Okay, so what's happening here really is that when we multiply something by 4, it's called a vertical stretch. And what it does is it makes this function really skyrocket because we're multiplying it by 4, right? These numbers are going to get big really quick. So this becomes more steep. I forgot that. That's important. All right, so my domain, remember my domain is the values that the x can be, all right? And if you look at the graph, this is going to go on forever. It's going to hug 0. It's going to go on forever. So it covers all these values of x. And over here, this also is going to go on forever at an angle. So it covers all these values of x. So my domain is all real numbers. Now my range is a whole nother story. Okay? This hugs the x-axis. It's never going to come down here. We don't have anything down there. So if I'm looking at just the y values, I could even look at it like this. If I'm looking at just the y values, I see that y is bigger than 0. Okay? These are my y values, and they're bigger than 0. Okay, so I know those domain and range ones can be a little tricky. Okay, we will do this next problem on the next video.